Good day. Hi, I'm Samuel Xolo. So today we're gonna be looking at a math problem, optimization to be specific. So we're gonna be looking at the problem, which is rather very interesting. Optimization number 2, as you can see, talks about pizza. So the problem goes that if you are offered one slice of a round pizza to be cut as a sector the regular way, and then slice must have a perimeter of 60 centimeters. The question is, what diameter of the pizza would give the largest slice? So I will just outline the problem in the paper and just draw an outline. So I drew my little pizza. So it's always a best way to draw the problem in order for you to visualize it, in order to optimize it. So we have here a pizza-like circle. What we want to do is look at what you're given. We are given a perimeter, so we must derive the perimeter, the formula for perimeter of a sector of a circle, because the pizza is in a circle, and then go on forth from there. As you can see drawn here, so I forgot to mention that the sector has like two sides which are equivalent to the radius. So we have two straight lines here, as you can see, two straight lines which are equal, and then there's an angle which you can name theta in between the sector. So the formula for the perimeter is P is equal to 2r, which is the radius, this is the radius, plus the radius times the angle in between the two radii. So yeah, as you can guess, we're going to need area 2 to go through this problem. So the area of a sector is half angle theta times the radius squared, the same angle which is in between the two radii in the sector. So we're going to need area 2 to work through this problem. So what's going to happen is that we're going to take what you're given, and then which is the perimeter, and it's going to take the formula of the perimeter and equal to 260, and then we're going to solve for theta, which is the unknown in this case, because theta is there in the formula for the area of a sector and for the perimeter. So we're going to take the 60, which is we know, and then equate it to the formula for the perimeter, and then after that we're going to solve for theta, and then take that value of theta and plug it in the formula for the area. So now working with perimeter, trying to find the theta, the value of theta. So from what's given, the equation, as you know the equation, so given the perimeter of the sector of the slice of pizza, you might say, is 60. So we equate 60 to the formula for the perimeter, and then we transpose. Rather, transpose is a very taboo word in maths, but yeah, we transpose the theta on the other side, and then the 2r becomes negative on this side. And then if we divide by 2 throughout the equation, we find that theta is equivalent to 30 minus r, which is the radius of the circle, or the pizza rather. Yeah, so now we're gonna use the theta and substitute it into area A, which is the area of the sector. So when you do so, we have first the area formula of the area of the sector, which is equivalent to theta over 2 times by r squared, which is the radius of the sector. So we get a new value for A, which is 30 minus r all over 2 times r squared, which can be simplified to 30 r squared minus r cubed or over 2. This is the new value of A. So what you're going to do is we're going to use this value. We're going to use calculus to optimize by using calculus, and we're going to derive this A to get A prime, which we're going to use to find the optimization. Yeah, now we have A. What's going to happen now is that we're going to get a derivative of A, which is A prime, which we got it in fact. So this is A, as you saw it previously, and then we're going to derive it to get a prime, which is 60r minus 3r squared all times 2, which is all over 4. So in case you're wondering how we got here, we derive a, as I said, using the quotient rule. What happens is that we derive the numerator and then times it by the denominator, and then derive the denominator times it by the numerator, and in between there's a minus sign, and then we square the bottom, which is the numerator, the denominator. Excuse me for my hiccups and my bad handwriting. So as you can see, there's no other part here. This is due to since 2 is a constant, when you derive it you get 0, so the other part just went away. And then this is the a prime when simplified. So from here, what you're going to do is that you're going to solve for r. We're gonna make a prime derivative to be equal to 0, and then solve for r to get our maximum diameter for our pizza. So when we equate a to 0, we get something like this. It's like this, and then we solve for r. So what you do, we cross multiply first, and then 2 times 0, because there's a 1 over the 0, so 2 times 0, and then there's a 1 over the 0, which is this quantity times 1, which is the same thing. And then we factorize. We factor r out to be left with, in brackets, 60 minus 3r. Excuse me for my pattern writing. This is 3r. So the 60 minus 3r in brackets. So we know from the rules that when we want to solve, the r is going to 0 by itself. So r is either 0 or r is 20, because when we have 60 minus 3r, what happens is that the 3r will be transposed. So it's going to be 60 is equal to 3r, and then we divide by 3 to get r, which is 20. So obviously from the looks of it, you can deduce just the r for our maximum is not 0, but the r is actually, and this makes a diameter to be just therefore 40, which is 2 times r, the radius, and that means our pizza has a diameter of 40, which is quite a big pizza, by the way. Thank you.